Now the next a very important we are going to see, that is nothing but your Lenz law. So what this Lenz law it states, so this will state about the direction. Yeah, so it will just give you the idea about the direction of your induced EMF. Yeah, so we have just seen that. So this is nothing but the magnet. When you just move the magnet in the downward direction, we say that so the current flow through the coil in the anti-clockwise direction. Now why it is anti-clockwise? Yeah, so why not clockwise? So the reason is that obviously we can say that when you move the magnet in the downward direction, yeah, so obviously now so the flux link with the coil gets changed. So the law states that obviously so that the direction of induced EMF will act in a such a way that it will oppose the cause. Yeah, so the direction of induced EMF, it will act in a such a way that it will oppose the cause. Now why the EMF has been induced into this your circuit is mainly because the motion of your magnet. Yeah, so the induced EMF has to oppose that motion. So how he is going to oppose it? So definitely simple, you can say that so this is a coil, yeah, and through which the current is flowing in the anti-clockwise direction, so which is similar to that of your north pole. If you know that, so whenever there is a flow of current through the coil in the anti-clockwise direction, so it will act as a north pole over here. So definitely this will act as a north pole, and since this is also north, so there is some repulsion. Obviously there is a repulsion, so the induced EMF is now going to oppose that cause. So definitely how he will oppose the cause? By making the direction of current inflow in a such a way that obviously so that it will act as a himself as a north pole. So definitely because of which it will oppose that cause. So this is what we call as a Lenz law. Yeah, so the direction of induced EMF will act in a such a way that it will oppose the cause. So similarly this is valid for your all the examples. So this we are just taken the second one also, where we said that so when you just move the magnet now away, so when you move the magnet away for this case, so again the cause, the EMF is induced because the motion of the magnet away from it. Now since it is moving away, so that is responsible to induce the EMF. So now the current will act in a such a way that again it will just oppose, yeah, it will oppose that the motion of the magnet which is moving away. So it will just try to attract it. Yeah, so he himself will act as a south pole. Yeah, so there has to be the attraction, so it will oppose that cause. So that is what we can say about the Lenz law. So this is what we have seen about the Lenz law. Yeah, so which is used to determine the direction of your induced EMF.